For years, we've thought of AI as this digital brain living up in the cloud, something behind our screens. Well, 2026 is the year that brain gets a body. Seriously, this is the moment AI is stepping out of the virtual world and into our physical one. So let's dive into how this all happened. So here's what we're going to cover. First, we'll talk about how AI even got a body in the first place. Then we'll see it in action on a real factory floor and unpack the software that makes it all tick. After that, we'll look at the major players racing to build these things, separate the hype from the hard reality, and finally, ask the big question: what does this all mean for us and our jobs? All right, first up, the great embodying. How did this massive shift from digital code to physical robots happen? And why is it all coming together right now?
NVIDIA's CEO Jensen Huang said this back in 2025. And looking around now in 2026, wow, it feels less like a bold prediction and more like he was just stating the obvious. This isn't just about simple automation anymore, it's about true autonomy. And that brings us to the core idea here: physical AI. The key thing to get, and the slide really nails it, is that we're talking about a huge leap beyond just pre-programmed robots. These are systems that can actually see the world, think about what to do, and then learn from what happens. It's totally closing the loop between digital thought and physical action.
So to see how this is all playing out in the real world, we have to get out of the lab. We need to go to the ultimate proving ground: a busy, high-volume car factory. This is where the rubber really meets the road for this technology. And this was a huge moment for the industry. Late last year, Figure AI put its Figure O2 humanoids to work at the BMW plant in Spartanburg. And look, this wasn't just a demo for the press. This was the first time ever that humanoids were fully integrated into a live high-pressure assembly line. And they weren't just showing up for a quick photo op. These robots were put through their paces, working full 10-hour shifts. That's a huge deal. It proved they have the kind of endurance you need for serious industrial work, working right alongside human teams. And get this, during that trial period, the robot fleet handled over 90,000 individual parts. That's not a typo, 90,000 parts, all loaded onto the production line with incredible precision. So what was the result of all that work? Well, it contributed to the assembly of more than 30,000 vehicles. The pilot was a massive success, and it proved to everyone that physical AI wasn't just possible, it was economically viable. That's what really kicked off the investment boom we're seeing right now. Okay, that performance on the factory floor is just incredible. But it does make you wonder, what's actually going on inside the robot's head to make that possible? The hardware, the brawn, is only half the story. So let's look at the software revolution, the brains, that makes all of this work. The big breakthrough here is something called a Vision Language Action Model, or VLA for short. The easiest way to think about it is like the AI's central nervous system. It lets the robot connect what it sees with its cameras to what it's being told to do in plain English, and then translate all of that into a physical action. See, hear, do. What's so amazing here is the jump in how these models think. On the left, you've got the old way, where an AI would reason based on a text description it was given. But look at the right. The new model can actually go back and look at the image again and again. It's not just thinking about a description. It's actively looking at its world in real time to solve problems as they come up. It's a total game changer. So with the software and the hardware finally coming together, the market is just exploding. And what we're seeing now is basically a horse race between some major players to build and define the entire future of physical work. And right now, two of the biggest names are taking completely different approaches. You've got Tesla with their classic audacious vision. They want to use their manufacturing power to build Optimus, a low-cost robot for pretty much everyone. Then you have Amazon, which is being way more pragmatic. They're not trying to sell you a robot. They're perfecting specialized robots, like Digit, to make their own logistics empire even more unbeatable. And this chart kind of gives you a snapshot of the whole field. It's pretty clear there are two things you need to succeed here: deep-pocketed partners, look at OpenAI backing both Figure and 1X, and a really clear idea of who you're selling to. And even the original pioneer, Boston Dynamics, is now shifting gears to focus on commercial products with Hyundai's help. It's an incredibly fast-moving and well-funded race. All right, after seeing all that incredible potential and hearing about these massive multi-billion-dollar bets, it's time to take a breath. It's time for a reality check. There are still some huge engineering hurdles separating today's robots from, a robot in every home. One of the biggest problems is what they call the sim to real gap. So, in a perfect lab simulation, an AI model might work 95% of the time, which sounds great. But the moment you put it in the real world, with weird lighting, messy floors, and just unexpected stuff, that reliability can absolutely plummet. And for a factory that needs to be running 24/7, that's a total deal breaker.
And then there's the hardware itself. For all the genius AI, the biggest bottleneck for most of these humanoids is just battery life. The typical runtime right now is only about 90 minutes. That is a long, long way from the 8 or 10-hour shifts you need in a factory. And maybe the most humbling reality check comes from a true pioneer, Rodney Brooks. He points out that for all the amazing progress in the AI brains, the physical hands, the part you need to actually do stuff, haven't really gotten much better in decades. So the takeaway is pretty clear. The AI brains are moving at light speed, but the physical bodies are still struggling to keep up. Okay, so finally, let's get to the question that is on absolutely everyone's mind. What does all of this mean for our jobs? Are these robots coming to replace us, or are they here to work alongside us?
So, on one hand, you have the fear of massive job losses as robots take over all the repetitive, dangerous, or just boring tasks. But the reality that's starting to emerge is actually a lot more nuanced. The focus is much more on collaboration, using robots to fill really critical labor shortages. And what's interesting is it's creating totally new jobs that didn't exist before, like robotics fleet managers or human robot safety specialists. So, why does all of this matter to you? Well, because physical AI is already helping with labor shortages that affect the stuff we buy every day. It's going to completely change how things are made and delivered. It's also forcing us to figure out a whole new set of rules for safety when humans and robots work together. And don't forget, what's happening in factories today, that's just step one. This same technology is coming for healthcare, for retail, and yeah, eventually for our homes.
Which leaves us with the ultimate question, doesn't it? We hear these predictions about a $1 trillion market, a future with a humanoid in every home. But we also see these huge challenges with batteries and reliability and just getting the hands to work right. So as we stand here today in 2026, is this the dawn of a truly incredible future? Or is it still just very, very clever science fiction? I guess that's the question we're all going to be answering together.